Good morning. My first video today is going to be in the geometry field. I gotta kind of pump some out for each one of my classes so that they can do some of their work. I actually enjoy doing this, not the videos. I hate my voice on video, and apparently I blink all crazy on video, but that's okay. I like teaching my kids. It's easier if they were in the classroom. My classroom is empty. But I hope I can help them, and maybe they can focus a little better, more than they do in my class. But if you're following along, whether you're in my class or not, we are starting with geometry this morning, and mainly area. We have area of the square, rectangle, triangle, parallelogram, and trapezoid. My students have a few worksheets that we were kind of reviewing area on, so that's where I'm getting my information at. However, this will apply to any area that you are doing in your geometry class, whether it be middle school or high school. So we're just going to go ahead and jump right in. I moved to this board. There's a little less glare. Unfortunately, it's an old smart board, so it doesn't erase very well. But it's what I have right now, so that's what I'm working with. So the worksheets that we have, if you're in my class, we're on worksheet 28 and 29. First, deal with the square, the rectangle, and the triangle. If you can see the worksheets here, it is a matching unit, but the application of it all is still the same. So we're going to start out, and I'm going to do a couple of each shapes with them just to remind them how to do this. So if we start out, the first thing we got up here is square, so we'll go ahead and start out with a square. We have a couple applications of squares here. My squares will not be perfect squares. I don't have the time or the editing capability right now to do that, so we're just going to pretend that that is a square, a sad one at that. And they also give us another square, and it has a Z. Now you'll see me write most of my Z's with a slash in between them. And it's because sometimes if I'm in a hurry, my 2's look like Z's and it confuses the kids, so I put a line through them. So that is a Z. And this also gives a little bit more information. Okay, so the area of a square is the side squared or the edge squared. It's still length times width, just like a rectangle. The only difference is that in a square, all sides are the same. And so instead of saying length times width, which you could do, it says the side squared. Well, 10 squared, or 10 times 10 equals 100. Now a general rule, and I didn't write this up there, shame on me. Oh, not shame on me. This worksheet just says units squared. It does not give inches or feet or anything like that, but when you're doing area and measurement, you do want to put your unit. So this would be 100 units squared. It's kind of weird that they did that, but if it's centimeters or whatever, you do need to put that. And anytime that you're multiplying the two sides together, when you're doing measurements, you're going to get a squared in the situation. Okay, so if you were in my class, you would draw the line from here to 100 units squared, wherever that is on your worksheet. All right, if we're looking at this one, it does not tell us the side, okay? If you haven't noticed by now, and we're toward the end of the year in geometry, it is a logical thinking class, and not everything is up in your face and they give you everything that you need. You have to think about it, mainly in the proofs, but in this, they don't give us a side, so how are we supposed to square Z? Well, you can also remember perimeter is all the way around something, like walking around it, okay? So it would be all of the sides added up, okay? So in a square, there's 1, 2, 3, 4 sides, right? So that would be a Z plus a z plus a z plus a z equals 28, or 4z equals 28, because z plus z plus z plus z equals 4z. Okay, in the rules of Algebra 1, we have to get z by itself, so we divide, and we would get z equals 7. So z is 7. Now, have we answered the problem? No, we have not answered the problem. We still need to square z. So 7 squared, or 7 times 7, is 49. So this one would be 49 units squared. Okay, I get this question a lot in all of my math classes. If you're a high school math teacher, probably a middle school math teacher too, you get, why do we have to learn this? And why do I have to take Algebra 1, then Geometry, then Algebra 2? The question number 1, why do we have to learn this? I always answer with, you have to get out of high school. You have to pass my class and get out of high school. So for now, that's why you need to learn this. For the question is, why is there an order to Algebra 1, Geometry, and Algebra 2, is because you need a grasp of Algebra 1, a little bit of it, in order to do geometry. You need a little bit of geometry in order to do Algebra 2, because that's where trigonometry and things come in there, coordinate geometry, things like that. So that's why there is an order to it. Not saying that you couldn't go from Algebra 1 and Algebra 2 and still pass, but you'd have to learn a few new things. So this is kind of the pecking order, so to speak. So that's how you do squares. So let's look at rectangles. On the rectangles, we have a perimeter one as well. I'm not going to go ahead and do that. You just seen how I did a perimeter problem. So I'm going to do a rectangle that is different from that. Oh, this is a sad rectangle. And I did it backwards. Well, pretend that line wasn't there. Okay. I have this weird rectangle that is separated into two triangles by a diagonal. And yes, I have a trouble saying the word diagonal. They give me one side, but they don't give me the other. In a rectangle, you have to do length times width. So it looks like I'm missing my length. How do I find that length? Well, they gave you a right triangle, so you have to use a skill that you've learned probably in Algebra 1 and definitely in this class if you've been in my class, is the Pythagorean Theorem. Because we have a right triangle and we know two sides of it, we can find this side, which would give us our length. So they give you a little extra work to do here. So the hypotenuse is the side that is across from the right angle. It is always the c in the a squared plus b squared equals c squared. And sometimes they write it c squared equals a squared plus b squared. Doesn't matter which way you write it. This is always the c squared, the one that's across from the right triangle. That's called the hypotenuse, okay? And it's important. So if we fill in what we know, all right, our c squared is 13. I said I was going to write bigger on this video because my other one I was writing a little small. So I'll try to remember that through the rest of this. 13 squared equals, your legs of your triangle could be A or B. It does not matter which order that you put them in. So I'm going to go ahead and say 5 squared plus B squared. This is my equation. I'm going to move this out of the way. Trying to hurry up when I erased things yesterday. It took a little longer than I would like, and I will start to edit these videos, but for now I don't have the time. I'm just trying to get the content out, but I will start at least next week editing these videos so that you don't have so much dead space and they're not so long. So we have this equation. So 13 squared, I believe, is 169. I'll double check that in my calculator. 5 squared is 25, and that equals b squared. All right, again, we come back to algebra in our work here today. I need to get the variable or the letter by itself. So 25 needs to move. Anytime you move anything across the equal sign, you do the opposite. This is a positive 25, so I must subtract 25. Let me double check that. I'm almost positive I'm right, but I've said that before. Yeah, okay. So now we do 169 minus 25, which I believe is 144, equals b squared. We are not done. A lot of people would want to finish here because we have the variable by itself, but it's still got the little exponent on it, and you have to undo that as well because we're not solving for b squared, we're solving for b. If this is a and that's c, this is b, I need plain old b, not b squared. So to undo a root, when you're doing equations, you always do the opposite. If this is squared, the opposite of squared is to take the root or the radical. All right, so the square root of b squared is just b, and the square root of 144 is 12, and you can do that in your calculator by using the button that looks just like this. That is your square root button. Okay, so b equals 12. So we did all that. We still don't know the area of this rectangle, but now we have the information. I have a 5 and I have a 12. So if I do length times width, area equals 5 times 12. And 5 times 12 is 60, so the area is 60 units squared. Okay, a lot of work for a rectangle, but that's how you have to do it. So all of these on the assignment that you have are not so cut and dry. You have to kind of think outside of the box for some of them. We're going to move on to triangles. I'm going to erase this as quick as possible. Okay, I realize it's not Greek, but it's what I'm working with. All right, so a couple triangles on here. I'll do my best. This is the top right one if you're following along on the paper. Okay, and on the paper I went ahead and filled in the height, but again, this is a problem we're going to have to do Pythagorean Theorem in. All right, I have a triangle, so this is the area that I'm looking for. Area equals 1/2 the base times the height. Well, generally the base is what it's sitting on, but in a triangle, it could sit on any side. So you really got to pay attention to where that height is, because the height and the base are going to be perpendicular, which means one line goes this way, one line goes that way. They make right angles, okay? So I know this is the base. All right, so the half is a constant in this equation. It's not going to change, okay? I don't yet know the height. It is not this 15 over here, okay? So as of right now, I'm going to do 1/2 times the base. The base would be both parts of this, 9 plus 15. All right, so 9 plus 15 is 24. So this would be 24, and then times the height. So I still need my height in there. So we're going to work on that. Well, again, this little box right here, and there would be one on this side since this is a perpendicular line, makes a right triangle. Anytime you're dealing with any kind of shape that makes a right triangle and you know two sides, you can always do the Pythagorean Theorem to know the other side, but it only works in the right triangles. So in this case, I'm going to look at this one because I know this is 15, and I know this is 9, but I don't know this side. Again, across from my right angle is the hypotenuse, which is my C. So that is 15 squared equals, I can call this A, I can call this B, and we'll call that one C. All right, but the C is important. A and B can be interchangeable. C has to be on the side by itself. All right, so then this would be 9 squared plus B squared. Well, don't write like I do, please. All right, so 15 squared, I think it's 225, but I don't always trust my skills. It is 225. 9 squared is 81, that's 9 times 9, and then I have B squared. I'm going to again use algebra, and I'm going to move this 81 over here. It's positive, so I'm subtracting it, okay? 225 minus 81 is again 144, which is what the last one was, equals B squared. Those canceled out. 81 minus 81 is nothing. And then this is 144. So like I said before, to undo the squared, you have to do a root. Square root of B squared will be B, and the square root of 144 is 12. So now I know that my height is 12, so this H right here is no more, and it's now a 12. So now all I need to do is do the multiplication, and I'll know the area of this whole triangle, not just this part, but the whole big triangle. Okay, so when there is a half on here, if you don't have a calculator, the trick is to take, if it's an even number, half it. Okay, 1/2 times 24 is 12. All right, half of 24 is 12. And then 12 times 12, we've already learned, is 144. So this triangle is area equals 144 units squared. All right, so we will do one other triangle. And this is at the bottom left column of our page. And it looks something like this. And it looks like you're not going to get away with any triangles without doing the Pythagorean theorem. All right, so the question on this triangle that I get a lot is, how do you know what's the base and what's the height? All right, this, the hypotenuse, right? That's our C when we're doing Pythagorean theorem. Okay, this is supposed to be a straight line. Mine is not very straight. This is a straight line, and this is a straight line. The two lines that make that right angle have to be your height and your base, okay? So if I don't know this, and if I flip this triangle around, it does not look the same, okay, but we can pretend, okay? If I flip this triangle around, this would be my 4, this would be my 5, and this is my height, okay? So this is the height that we're looking for, not the base. However, if you are confused about all that, it's not really going to matter because it's multiplication. Base and height can be flipped around. It will matter if there's another option, another number. If you put the wrong number in there, you're not going to get the right answer. I'm probably confusing you. I'm sorry. All right. So in this case, we got a Pythagorean theorem this side. So this time, I will make that A, that B, and that C, just to switch it up. All right, so my C squared would be 5 squared. Remember, this is C squared equals A squared plus B squared. I feel like I'm whistling every time I say squared. I apologize for that. I'm not a fan. 5 squared, A squared plus 4 squared, because that's my B. So 5 times 5 is 25. And 4 times 4 is 16. So I move my 16 over, and I subtract it because it's positive. I want these to cancel out. So 25 minus 16, I believe it's 9. I feel like I'm gonna look stupid with my math skills here, but yes, it's 9. 9 equals a squared. Take the square root of both. Square root of 9 is 3. So a equals 3. That is my height. All right, the height of the triangle is 3. So when I plug this in, this formula, we'll do it right here. I know this is a mess. I apologize. This is how I do my real class. The base is 4, and my height is 3. 1/2 of 4 is 2, and 2 times 3 is 6. So this is 6 units squared. Okay? Now we're going to switch to the next page and the parallelogram and the trapezoid. And the trapezoid is the only one that'll probably give you a problem. Parallelogram's not much different than a rectangle. So I will erase this as quick as possible. Okay, hopefully that's not too much of a mess. It is for me, but... Alright, our next lesson is area of a trapezoid and area of a parallelogram. These are the two equations, and you can see this one is the most complicated one that we've seen thus far. A lot of people have a misconception about... Sorry, I needed to get a drink. Have a misconception about trapezoids, that they always look like that. That is not so. A trapezoid has to have two bases, and then the sides do not have to match. Okay, so you're going to see shapes in here. If it's not a parallelogram on today's paper, it is a trapezoid, and they're going to look different than this trapezoid right here. Parallelogram, by definition, is a polygon where the opposite sides are parallel. So this side and this side are parallel, and that one and that one. You know, parallel means that they will never cross paths. They are like straight. So we will jump right back into this, and I will write a couple problems, and we'll do a couple parallelograms and then a couple trapezoids. So with number 1, and yes, my drawings are going to be horrible. And then we will do number 12. I don't know if I can do number 12. The drawing is kind of, we're pretending that is a parallelogram, okay? Alright, so when we're doing the parallelograms, I'm going to switch colors just for effect or something, I don't know. And the parallelogram is base times height. All right, so you need the height, which again goes from the bottom to the top, but it has to make a perpendicular line in order to be, the height is like from one point all the way up to the apex of it. So in this case right here, because this is the parallelogram, even though this side is 24, this side also has to be 24 centimeters because they're the same in a parallelogram. So our base area equals our base, 24 centimeters, times our height, which in this one is 10 centimeters. Well, 24 times 10 is 240. So this would be 240 centimeters squared. Okay, so that one's not much different than a normal rectangle, except for we're using base and height, not length and width. All right, so 12, the parallelogram is kind of tilted on in. So you got to look to that height line, which would be this one that makes the perpendicular here, to find out what the base is. This is the base. We are missing part of this base right here, and we know this side, and we're missing the height. And I forgot to write this side was 5 inches. Okay. So first of all, let's go ahead and fill in this little piece right here that we're missing. In a parallelogram, parallelogram, the opposite sides are the same. So if this is 5 inches, this whole side has to be 5 inches, which means this part has to be 3 inches because 3 plus 2 makes 5. Okay? We need that in order to find the height. All right, so now we have our right triangle, and our hypotenuse is across from that. So our C is 5 squared. Our A would be 3 squared. And our B, we don't know. So again, using the Pythagorean Theorem, I might as well just write it up here. Either way you look at it, it's still the same. All right, 5 times 5, 25. 3 times 3 is 9, and we got b squared. Again, the laws of algebra state that we have to undo this by doing the opposite. 25 minus 9 is 16, and then we have b squared equals 16. We are not done. We have to find regular old b, so we have to take the square root of each. So this will be b, and then the square root of 16 is 4. So now we've found our height, which is 4, and we can do base, which is going to be 5, the whole length. So area equals 5, and then our height is 4. 5 times 4 is 20, so area equals 20. No, this is not units, this is inches. Don't write units. Inches squared. And that's parallelograms. All right, last on this video is trapezoids, and then I'm gonna take a break and then start a new video. So the last one is trapezoids. And they're a funny little shape with a lot of different parts, but not too complicated. So I hope this video is not extremely long. I'm kind of trying to talk fast, but trying to also articulate. Let me dry this off just a little bit so that I can write on it. Okay. Trapezoids, this is the last one. So this is the formula that we're using. I need to step off camera to get a drink. It's sweet tea, by the way, in case anybody cares. And on this, worksheet 29, which looks like this, for the trapezoids, we'll do problem 3. Boy, my artistic skills are going down hill this morning. And I will do problem 11. Every time I teach a class, no matter if it's a worksheet or book work or whatever it is, I always give examples throughout the page. And we do them together as a class, and generally my class is here so they can ask questions, ask me how I got something, or where it came from, or stop, I don't understand what you just did, or something of that nature, so that they can see the process work. Nothing worse than doing math and you're in class and you've seen the lesson or you read the lesson and you're like, yeah, it sounds simple enough, and then you go home and do homework and you look at it and it doesn't even look like the same stuff you did in class. You're like, what? I have no idea. So I require that my students, when I do examples, they're written at the top of their page, and that is a reference for them so that when they answer their questions and they get stumped, they can first look at the top of the page and say, okay, this is a step, and I usually write steps on the board if they're necessary. This is a step, this is what she did, this is what she did, let me try that. They need to do that before they come up to the desk to ask me. If they did that, when they come up to the desk, I'll say, okay, did you do this? Yes, yes, yes. And then I'll go back and work the problem backwards with them to see. A lot of times it's just they didn't read their own writing. They wrote it down wrong. I wrote it down wrong. That happens. Make mistakes sometimes, yes. But we get to the point. But in math, unless you do it for yourself over and over and over, you'll never get it. The reason the kids are like, how come you're so good at math? First of all, I'm not really that good at math, okay? I did well in high school. I did okay in college, although it took me a minute to remember things. But I do it every day, so it's kind of fresh in my mind, and the more I do it, the more I retain it. And that's the same thing for students. So practice, practice, practice. I know nobody wants to sit around practicing math, but that's how you get better at it. So if you need to get better at something, whether it's factoring or multiplication or anything, just do more of it, and that's going to help. Frequently, extra credit. I make my kids write their multiplication tables. You'd be surprised how many kids make it through to high school that don't know their multiplication tables unless they have a calculator, and that worries me. So practice, practice, practice. All right, so trapezoid. Problem number 3. We have this weird shaped trapezoid. Mine, the one actually has a little bit bigger of a slant here, so I'll make mine kind of look a little bit better. It's sad, but yes, just because it doesn't look like this, it's still a trapezoid. It still has 2 solid bases here. Does not matter in the trapezoid. You have a base 1 and a base 2. Doesn't matter which one is base 1 and base 2. That's a good thing about multiplication or addition. You can do it interchangeably. 2 plus 3 and 3 plus 2 are still the exact same thing. And it's the same way in multiplication. One of those lovely math properties that you probably don't remember. So our area says 1/2 times the height. Now remember, to find the height, you need to find the right angle or the perpendicular lines, which would be this one and this one. Okay, so our height is going to be this line. Okay, if we turned it over, this would be a base and that would be a base. Even though it's going down, it's still the height. I'm not going to flip it all the way over. So you just want to find the perpendicular line that goes like the to the top or the bottom, from here to here, here to here. So in this case, our height is 12. And then we must put parentheses. They, oh my gosh, I lost my train of thought. I don't know what I was going to say, but they represent multiplication in algebra and geometry and things like that. The dot, the multiplication, or just writing letters beside letters is all multiplication, so you need to remember that. So now base 1 and base 2 will be what the height is connected to, the 2 things of the height. So in this case, it's 14 and 9. It does not matter which way that I write them. Okay, these are all meters, and meters does need to go in your answer. I'm just showing the math portion, and then I'll put it in my answer. So when you do this, you gotta do order of operations, and you need to work the inside parentheses first. 14 plus 9 will be 23. Okay, and then since everything else is multiplication, we can just go straight across. Half of 12 is 6. So 6 times 23 is going to be our area, which is 138. So area equals 138 meters squared. Okay, so that's a basic trapezoid, and they gave us everything we needed. Unfortunately for our assignment, they're not probably going to give you everything that you need. You're probably going to have to do something to find them. So this other one, and I want to make sure it's fully on camera. I think it is. Yep. This other trapezoid looks like a traditional trapezoid. It looks like this one in the picture. So you think it might be easier, but they left out some information, okay? We see our height lines are both right here, okay? We see that one base is 20 and one base is 10. So we can go ahead and fill that information out. Okay, area equals 1/2, which is a constant. It's always there. We don't know the height yet, but we know we have a base of 20 and a base of 10.